In this video, we're going to look at the idea of reciprocal numbers and see how that applies to the trig functions we've been looking at. So, two numbers are said to be reciprocals if the product of the two numbers is 1. So as an example, 4 and 1/4 are reciprocals because 4 times 1/4 is equal to 1. In general, if we have some number x, then 1 divided by x is its reciprocal because if we multiply these two things together, we end up with 1. So let's see how this applies to the idea of measurements we've been looking at in this course. So I have two segments here. We'll suppose the lengths of these two line segments represents the value of a and b. And what we'll do first is imagine measuring b in units of a. So if you look at this diagram, we see that b is 2 times as large as a, and therefore the measurement of b in units of a should be 2. So we have measurement of b in units of a is 2. But in general, we usually represent the measure of b in units of a as the ratio, b divided by a, and therefore this ratio has a value of 2. On the other hand, if we imagine measuring a in units of b, we should get a measurement of 1/2, because a is 1/2 times as large as b. We would represent this measurement as a divided by b. So what we notice is, if we switch what we use as our unit of measure and what we're measuring, we end up with reciprocal numbers because 2 and 1/2 are reciprocals. So if we measure the measurement of b in units of a is the reciprocal of the measure of a in units of b. Now this is with just some specific numbers or specific measurements, but in general, the measure of b in units of a is represented as b divided by a, and the measure of a in units of b is represented as a divided by b. So if you multiply these things, you're going to notice that we're going to end up canceling some things out. We're going to end up with a value of 1. So we're always going to have this reciprocal notion where if we measure b in units of a, it's going to be the reciprocal of if we measured a in units of b. So let's see how this applies to the trig functions we've been looking at. So I have this diagram here of an angle with a measure of theta radians. The terminal point is v units above and h units to the right of the center of the circle, and the radius of the circle is r units long. So we know that sine of theta gives us the measure of the terminal point's vertical distance above the center of the circle and units of the radius of the circle. And cosecant of theta gives us the measure of the radius in units of the terminal point's vertical distance above the center of the circle. So we're looking at the two links, the same two links there, but the one we decide to measure and the one we decide to be the unit ruler is being switched, just like what we looked at before with a and b. And therefore, we expect these two outputs to actually be reciprocals. All we're doing is switching what we're measuring and what we're using to measure. And therefore, we expect sine of theta times cosecant of theta to be equal to 1. And this then tells us that sine of theta can be thought of as 1 divided by cosecant of theta. Or you could also say that cosecant of theta is equal to 1 divided by sine of theta. Those two outputs are reciprocals. So in a similar way, since we saw that cosine of theta gives us the measure of the horizontal distance in units of the radius of the circle, and secant of theta gives us the measure of the radius of the circle in units of the terminal point's horizontal distance to the right, those two things should be reciprocals. And so we should have cosine of theta times secant of theta being equal to 1, which then tells us a little bit about how we could represent secant of theta in terms of cosine of theta. We could say secant of theta is equal to 1 divided by cosine of theta. And then in a similar way, we can do a little more with tangent, but what we're going to see is cotangent of theta is going to be equal to 1 divided by tangent of theta, because tangent of theta and cotangent of theta are reciprocals, in a similar way that we saw with cosine and sine.